Following the trigonometry complex number video, we created this page, immediate mode CAS variable, under the info section. Under the algebra section, we created a DIST function. If we look at the DIST function, there are three ways that we can create the CAS variable. The first way is to use the program editor, and the other two methods are to add the functions in the immediate mode shown here. The first method involves using begin, return, and end. When we look at it on our calculator, we only see the return. The begin and end do not show up. The third method is to use the abbreviated form. The abbreviated form does not include the begin, end, and return, and is shown here. We return to the CAS var page. We will add the functions to our calculator using the abbreviated functions shown here. First, we add slope of a line by double-clicking, then shift down and click, Control-C, go over to our calculator and Control-V. Press Enter. Next, we add line, point, slope. Turn to our web page, double-click, shift-click, Control-Copy, turn to our calculator, Control-Paste. Press Enter. We go back to our web page and add the line of 2 points. Double click it, shift click it, Control copy, click on our web page, Control paste. Press Enter. Now we have the three functions added to our calculator. Returning to our web page and clicking on the lines page, we go back to the functions and their graph from finite math for doing straight lines. Here we see the Texas Instrument version of the page. Stalling HT functions shows us two different methods to do it. The abbreviated form that we chose to use was the alternate nested approach. We like the nested approach because this helps us build up a library of functions. Our final step is to look at how we use these functions. We go back, we click on using the HP programs, and we scroll down a little bit so that this window is in the middle of the page. Looking at the screenshots shows us using the longer abbreviated form. If we look at our calculator, we see we use the shorter form because we do not see the return. Remember, the begin and end do not show up even with the longer form. We will just go to using the slope of the line, check out the rest of the screen. Let's clear out our calculator. Press Shift and clear. Press the var key. Press Program, which is 2. We see that we have in our calculator the three functions: line, point 1, point 2, line, point, slope, and the slope of a line. We also have in our function the polar to rectangular to polar, and the DIST that we did earlier. So we will want to go to option number 6. And in option number 6, we need our parentheses. Then we enter our numbers, -2, 9, 1, 3, and press Enter. We see that the slope of the line turns out to be -2. We select the item, copy it down, we go inside the function, get rid of the parameters that are here, and enter new parameters. -4, 6, 5, 6. Press enter. See that the slope here turns out to be -2. We skipped the second example, so let's go back and work the second example. Copy it down. Go inside. To delete the parameters. -4, comma, 10, comma, 3, comma, -4, press enter. And this turns out to be -2. What we're doing here is looking at several different situations. Here we look at the situation where the y coordinates are the same, so we have a horizontal line which has a slope of 0. Let's copy it down again. Let's go inside, delete the parameters, put in 2, comma, 3, comma, 2, comma, -5, press enter. Here we turned out to be plus or minus infinity. This is a vertical line. Next, we clear the calculator. Press the var key, press program, select option number 4, hit parentheses, enter the parameters -3, comma, 2, comma, 4, comma, -1, and press enter. Notice that we come up almost with the answer they have here. We have a lowercase x, they have a capital X. The problem with using a capital X is that the calculator stores 0 in capital X. It does not store 0 in lowercase x. In the abbreviated form, we decided to use the lowercase x in the simplified form that does not have the begin, return, and end. We now press the simplified key and get our answer to be -3x plus 5 equals 7. Over here, we have y equal to that value. This creates a problem in the new version of the calculator because the y equal used to be not allowed, but now it stores this particular value in y. So what we want to do is slightly different than it's shown. We want to take the value here, copy it, and we want to subtract y. Press enter. Then what we want to do is we want to multiply the whole thing here by 7. So we're going to take 7 and we're going to take it times. We're going to hit a parentheses. We're going to go up here and we're going to copy it down and we're going to press enter. And we're going to simplify this. And we end up with this answer over here, written in a slightly different order for the equation of the line in standard form. A couple more points are in order. Over here, because we used capital X, it substituted 0 and actually came out with the wrong answer. The other comment is, since we can't use y equal, we probably should have said that this is equal to 0 to have it parallel what's shown here. We came up with the same answer as here. This ends our video.